Dear learners, creators, and future innovators, welcome to Learning Academy Foundation from Mr. Andrea. Today, we journey into the heart of software development, not just as a technical discipline, but as a craft of clarity, care, and continuous growth. Whether you are writing your first line of code or refining a complex system, the principles we explore today will guide you toward excellence. How to develop a code. Every great program begins with a simple idea, a concrete example that solves a specific problem. But true mastery lies in abstraction, the ability to generalize that solution so it can be reused, adapted, and scaled. What the abstract consists of: detachment, objectivity, analysis, thinking, new ideas, new information, education, plans, and support. Indeed, what is concrete is what it is like now. We can develop code by example, a function that calculates the area of a rectangle, or abstraction, a geometry module that handles multiple shapes with reusable logic. Abstraction is the art of stepping back, seeing patterns, and designing code that serves not just one moment, but many. To write a clean and maintainable code, I suggest you to download TypeScript application. This is a very mastering art of writing clean and maintainable code. Code is not just for machines, it's for people. Do it for your future self, your teammates, your students. Maintainable code is readable, understandable, and adaptable. Here are key techniques. Comments. Use them to explain why, not just what. A good comment is like a whisper from the past, guiding the future. We have Java doc comment that is appropriate for documenting a class or method for Java doc utility. For example, the main method is run automatically by the Java virtual machine. Or single line comment, it's appropriate for documenting a statement. For example, the following statement prints a string to the console. System.out.println, this first statement after the comment. And the multi-line comment is appropriate for commenting code that is not needed currently but may be necessary in the future. And then descriptive names. Variables like total revenue speak volumes more than just X. The variables can be divided in quantitative and qualitative. Quantitative, for example, age, 23 years old, 50 years old, and weight, 57 kilograms, 87 libras. And these quantitative can be subdivided in continuous or discrete variables. Continuous variables are like the height, for example, 156 centimeters, 172 centimeters, and the time, for example, 1 minute, 30 seconds. The discrete variables are like the quantity, 3 children, 37 apples, or the account number. And the other type of variables is qualitative. For example, eye color can be brown, green, blue, or hair color can be black, brunette, blonde. For comments, descriptive names, indentation. Structure your code like poetry, each line flowing with purpose and clarity. I show you four styles of indentation: BSD, Linux, Haskell, and LSP. The difference in the indentation styles are the position of the brackets and the semicolon. And then comments, descriptive names, indentation, and finally, modular design. Break your code into functions and classes that do one thing well. So for example, this one is Linux style. So maintainable code is a gift for future collaboration. It's a legacy of thoughtfulness. How to program errors. How to identify and correct. Errors are not failures. They are invitations to learn. There are three general types of errors. Syntax or compile time errors. Syntax errors are grammatical errors and are detected when you compile the program. Syntax errors prevent your program from executing. So in other words, these are like typos in your code, and the compiler will catch them. This is an example of syntax errors where expected declaration specifiers mismatched are wrong. So the computer will tell you about this. And then runtime errors. Errors occur when you tell the computer to do something illegal. Runtime errors may halt execution of your program. So it crashes during execution and often due to unexpected inputs or missing resources. Execution errors occur when the computer is unable to execute a method successfully and stop crashes. So the computer tells you that there is an execution error program. Why in this case? Because any number cannot be divided by 0. So an execution error is occurring, will occur. And finally, we have logic errors. They are not detected by the computer. Logic errors cause your results to be wrong. So they are trickier. Your code runs, but the output is wrong. This requires deep thinking and testing that we will talk later on. Logic error is when your program compiles and runs just fine, but does the wrong thing. Very simple programs, logic errors are usually easy to find and fix if they occur at all. In all but the simplest of programs, 10% of your time is spent writing the program and fixing the syntax errors. More if you're still learning the syntax. And 90% of your time is spent finding and fixing runtime and logic errors. Logic errors can take hours or even days to find, so you have to allocate your time accordingly. To correct errors, we must first locate them. Tools like print statement, debuggers, and error logs become our magnifying glass. How to test data and plans. Testing is the discipline of trust. It ensures your code behaves as expected. What is a test case? Software test case is a detailed description of the specific steps to be taken to test a software application or system to ensure that it behaves as expected. They are often used as part of a broader software testing strategy that includes other testing methods such as exploratory testing, regression testing, and acceptance testing. We can test data, use normal boundary and invariant inputs to challenge your code. Can be normal data that the program should always work with. Normal data should be accepted by the program. Erroneous data is invalid data that the program should reject. And extreme data is boundary data that the program should accept. And then testing plans. Document your testing strategy. What are you testing? Why? What results do you expect? So specifying the product requirements, conducting formal reviews, and build robust software, specifying objective of testing and automation strategy, test schedule, and developing a test plan. Testing is not an afterthought. It's a design principle. Performance testing is a non-functional testing technique. Okay. How to debug, how to deal with errors. Debug is a detective work. Bug it means any error in a program. Developers term logged up back in 1945. Debugging is fixing errors. Debugger is a special software to help fix programs, usually part of IDEs like Eclipse. So it's where logic meets intuition. The process of determining the cause of a defect and correcting it is known as debugging. Debugging occurs as a consequence of a test revealing a defect. After a program failure, the programmer identifies the corresponding fault and fixes it. Programmers can locate faults by debugging a unit. The objective of debugging is to precisely identify the cause of a failure. Given the symptoms of a problem, the purpose is to isolate and determine its specific cause. Debugging is a time-consuming and error-prone process and involves a combination of systematic evaluation, intuition, and a little bit of luck. So how to debug? Trace the flow of your program, isolate the problem, and fix it with precision, and test again. Debugging teaches patience, humility, and perseverance. It's where coders become craftsmen. How to evaluate programs? By outstanding, excellence, or can be outstanding or excellent or very good or average or below average. A program is more than its output. We evaluate based on 6 steps. We establish stakeholders, explain what the program is about, select the design of the evaluation, collect data, generate conclusions based on data analysis, and state findings and provide recommendation. And then it comes back to establish stakeholders. So the parameters to evaluate are correctness. Does it was it's supposed to? Correctness is clearly the prime quality. If a system does not do what it is supposed to do, then everything else about it matters little. And then efficiency. Does it run quickly and use resources wisely? Usability. Is it intuitive for users? Usability characteristics are visibility, minimalism, error recovery, health, error prevention, flexibility, recognition, consistency, mapping, freedom. And finally, maintainability. Can others understand and improve it? So evaluation is a step of reflection. It's the moment we ask, did I build something good? What was good and bad about the experience? After evaluation comes analysis. What sense can you make of this situation? Follows conclusion. What else could you have done? And finally, the action plan. If it arose again, what would you do? And the action plan comes before description, what happened, and feelings. What are you thinking and feeling? So it's a reflection. This is a reflection cycle. Now let's have our Christian reflection. Think about the code as a calling. In Genesis, God spoke creation into being. Order from chaos, light from darkness. We can read, and God said, let there be light, and there was light. And God saw the light that it was good. You see, here there is evaluation also from God about his own creation, its own code. And God divided the light from the darkness. And God called the light day, and the darkness is he called night. And the evening and the morning were the first day. So as developers, we echo the divine creativity. We bring structure to complexity, clarity to confusion. Let us code, not just for profit, but for purpose. Let our programs reflect integrity, compassion, and service. Whether we debug a function or design a curriculum, may we do it with a joyful heart and spirit of excellence. As Colossians 3:23 reminds us, whatever you do, work at it with your whole being for the Lord and not for men. Work at it with all your heart as working for the Lord. Okay, let's close with invitation. If this message inspired you, taught you, or sparked curiosity, we invite you to like this video, comment with your thoughts or questions, share it with fellow learners or educators, subscribe to Learning Academy Foundation for more contents that blends beauty, rigor, and faith-rooted learning. Remind, a good teacher isn't someone who gives the answers out to their kids, but it's understanding of needs and challenges and gives tools to help other people succeed. Together, let's build not just better code, but a better world. We are better together. Thank you and God bless. See you on the next video. Bye.